in this example, the question that we're trying to do is to find the units of force F. To do this, we're given the information that we can use the equation F equals ma, force equals mass times acceleration, and we know the dimensions of mass and acceleration. As usual, we'll use the ACE-M problem-solving framework to solve this, which starts by analyzing the task and creating a plan. So why don't you take a minute to see if you can analyze the task and create a plan on your own, and then check in to see how you've done. All right, so in my analysis, I decided this was a pretty straightforward dimensional analysis problem where the goal was to find the units of F, the force. My plan is that I can use the given equation to find the dimensions, right? Since I have the dimensions of this side of the equation, I know the dimensions have to be the same across an equal sign. Therefore, if I know the dimensions of this, I can find the dimensions of this. Dimensions aren't quite the same as units, so once I have the dimensions, I'll have to transform them into actual units that we might use to measure something. All right, so what we need to do then is get the units of mass times acceleration. So we want the units of mass times acceleration, and we know from over here both of those. So the units of mass are mass. That's pretty simple. Acceleration is length over time squared. And there we go. We've already got the dimensions now of the force, right? Because the dimensions of the force equal the dimensions of mass times acceleration, which is mass of length over a time squared. All right, now what I want to do is put this from dimensions to units. And to do that, I just have to think what units do we use to measure a mass, a length, and a time. So why don't you see if you can do this step? Now this problem didn't specify what system of units to use, so I'm choosing here to use SI units, where masses are typically in kilograms, lengths are in meters, and times are in seconds. Now if you did this on your own, you might have chosen different things. Maybe you chose pounds here, feet here. You probably chose seconds for time, but maybe you chose minutes or fortnights. Any of that would be all right. But then what you do is you plug these units back in here to get the answer. So here, what we need to do is say this also equals a kilogram, plugging in for the mass, a meter, plugging in for the length, and on the bottom we need seconds squared. All right. So now we have the units of F, which we also sometimes write using the brackets. All right, so the units, we've achieved our goal. The units of F, they're kilograms meters per second squared. And in fact, this combined unit has a special name called a Newton, which we'll learn more about later on. All right, so the next step would then be a little bit of monitoring to make sure this makes sense. But as I mentioned before, monitoring with dimensional analysis isn't always necessary because dimensional analysis is usually a step of monitoring.